This is example 6D from note 6.3, day 3. It's actually an extra example that wasn't printed in your notes packet, so if you can write it down, that'd be great. We're given the magnitude of vector B as 7 units and the direction angle at 30 degrees, and we're supposed to convert this to component form. So I'm going to begin by drawing the vector. So I'm going to draw a coordinate plane, and then I'm going to put my vector on that coordinate plane with a direction angle of 30 degrees and a magnitude of 7. So this we'll say is 30 degrees, and the magnitude is 7 units, and I'm going to label this as my vector B with a little harpoon on top. So first, I want to find the component form. So if we think about right triangle trig, we can see that what we'd like to find is this x-coordinate down here and the y-coordinate up here. So from right triangle trig, I know that cosine 30 degrees is going to be my adjacent side. Let me call that x over the hypotenuse, which is 7. So that means x equals 7 cosine 30 degrees. And my y component, the vertical component of this vector, I can write that sine of 30 degrees is equal to the opposite, which is y over 7. So the y component of this vector is 7 sine 30 degrees. So my vector B in component form is going to be equal to 7 cosine 30 and 7 sine 30, and then I should put down what those values actually are. So cosine 30, if you remember, your right triangle trig is rad 3 over 2, and sine 30 is 1/2. And in terms of decimal approximations, if I do 7 times rad 3 over 2, which we can leave that, that's a perfectly good answer. So the exact answer, I'll write that first, 7 rad 3 over 2, comma 7/2. Improper fractions are fine. And then if we want a decimal approximation, if that's requested, I could say that 6.06, comma 3.5, punching that into my calculator.